Thanks. Hello, everyone. Cool. So as Luke mentioned, my name is Paul Bouwer. I'm a software engineer at Microsoft. So over the past 8 months or so, I've been working and talking about service meshes with a number of our top global customers and a number of our internal Microsoft engineering teams. And out of that, we've gained a lot of knowledge about what each of the service meshes offer, the capabilities, the performance overheads, the resource requirements, and some of the scenarios that best suit each of the service meshes. So what I'm going to try and do today is take you through this journey that I've been on over the last 8 months, distill some of that knowledge, and hopefully by the end of this, you'll have a better idea of what type of questions you should be asking, which meshes make sense for your applications, whether you should even be using a service mesh. Hopefully you'll be in a better position to actually implement something that makes sense for your environment. So what we're going to be doing is specifically looking at Istio, Linkerd and Consul. Those are the 3 main meshes that we're seeing customers deploy at the moment. So who here knows what a service mesh is? That's a good start. Who can describe what a service mesh is to the person next to you in 1 sentence? Yeah, confusing. So before I even get to the what a service mesh is, I'm going to ask why. Like, why are people so excited about service meshes? Why should you be using one? So to do this, I'm just going to look at a few scenarios, and these may resonate with you as we go through them. So if you look at a security scenario, typically, before we had microservice or cloud-native applications, the firewall was the security boundary. All of our IP addresses were static or fixed and were allocated via the operational team, and they were all encoded in the firewall, and everything was good. And all the internal traffic in your cluster or your workload or your ecosystem was unencrypted. As we've matured, as our workloads have matured, as we've moved into environments like Kubernetes, we're moving to this model of zero trust networks. So effectively, we've moved to a position where we trust none of the traffic. So we'd like to have it all encrypted. The other thing is, specifically within Kubernetes, all of our IP addresses are dynamic. So you never know what IP address your workload's going to get. This makes it very difficult to start locking down workloads using an IP address as an identifier, and therefore we need some sort of strong identity mechanism to identify each of the workloads and be able to secure the communication between them. Another scenario is delivery of software. Previously, we spoke earlier this morning about monolithic releases. We have known or fixed infrastructure. That's typically where we've come from, deploy everything together. What we're moving towards is businesses want things to happen faster. You may have multiple versions of your workload deployed in your cluster or in your environment at the same time. You may want to do progressive rollouts. So this is when you release 1% of your traffic, see how it goes. If things are good, you roll out to another 10%. Some businesses are saying, well, let's release these 2 versions and see what customers like, or which one is better, which one is getting better metrics back. And then canary releases are something also that people are interested in. And this is where you may roll out new functionality to a subset of your users, or either for testing or for slowly progressive rollout. Now, to make all of that happen, you need observability across all of your services. So you can implement this yourself, but it would be nice if something gave that to you. And then the last scenario that I want to talk through is resiliency and observability. So many of you have built applications where you would have put resiliency into your code. These are retries, back-off loops, all that sort of thing. And potentially some observability. So you could be gathering metrics in your application and pushing that off to some sort of external system. Now, in the past, typically you would have maybe one language that your entire company was writing applications in, and someone had approved a set of libraries that you could use to do this resiliency or backoff, and everything was good. Then we moved to the new world where you could have workloads running in Go, in Python, in Java, in C#, a host of languages, vetting each of the libraries for each of those workloads and making sure that each of them behave the same starts becoming a little bit more complicated. So there's a requirement for consistent observability and this resiliency and policy across all of our workloads. So hopefully that sets the scenario for why you would like a mesh. I'm going to go through some quotes now from a few folks to answer what a mesh is. So this first quote, the top bit is typically, when you ask people what a mesh is, you typically see that top bit. So service mesh, connective tissue, adds all these awesome capabilities, traffic control, service discovery, load balancing, resilience, observability, security. So that has ticked all of the boxes for the scenarios we just went through. The bottom bit is what we are starting to see a lot of people describe service meshes as, and I think it's a better description. A service mesh allows applications to offload all of these capabilities out of our code into the infrastructure. You don't want to have to be managing all of those libraries. Something should manage it on your behalf. And you can see this theme start to roll through a bunch of quotes that I've collected. So this is from Eric Bouwer from Google. He's talking about Istio. Decouples operational aspects from the implementation of the services. So as a developer, you concentrate on your application, and the infrastructure or the place that you deploy into should give you all those capabilities that we're after. And then William Morgan from Buoyant, they write Linkerd. Linkerd, this is also very succinct. Linkerd moves visibility, reliability, security constraints down to the infrastructure layer, out of the application layer. So as you can see, I think these last two quotes are probably the best way that I would describe a service mesh. It's taking all of those things that you'd like all of your applications to be doing out of your code. So what does a service mesh typically look like? So there are multiple implementations of service mesh, but typically these are the capabilities that you're likely to see in a service mesh. So I've broken them out into three silos. Some service meshes may break this up into different ways, but essentially you've got traffic management. All the service meshes operate at layer 7, so that's dealing with your application layer traffic. Some of them will also do layer 4 or 3, so they can also look at your TCP, raw TCP traffic. But typically, they're dealing at the application layer. And then they have some sort of way to do dynamic routing of your applications. That could be conditional, so if something has a cookie direct to here or to there, waiting, mirroring. Mirroring is very interesting. A lot of the meshes have this capability where you can essentially siphon off your traffic to another service, where you could either put it through a dev version of the service or just capture the traffic. And then you also have all the resiliency patterns we discussed. And then policy. So here you can do access control. You can say who can access each of the services. And that's not necessarily from a user point of view. It's which services can talk to each other and which versions of which service can talk to each other. You could potentially do rate limiting on each of your services or on different paths and quotas. Another very interesting thing is the testing. So you can actually, some of the meshes allow you to inject faults into your workloads. So they potentially could return a 200 on an HTTP request every 5th request, or drop every 5th packet. This helps you to ensure that your resiliency has been set up correctly. And then the security is also a very strong aspect of this. All of them offer mutual TLS. So this is just encrypting the communication between your services. Some of them do a better job at certificate management. We'll dig into some of that in detail now. But the certificate management and external certificate authorities is definitely something you need to keep an eye on when you're looking to deploy this with multiple clusters and as your setup matures. And then the last category there is around observability. We've seen a number of talks today talk about the importance of this. The metrics, you need to make sure that your service mesh gives you the golden metrics. If you're unsure what that is, look at the Google SRE handbook. Got a very good section on what the golden metrics are. And then most of them will give you a Prometheus or Grafana instances within your cluster. Tracing is also important, and then looking at aspects of your traffic, either within your cluster or the traffic that comes in or goes out of your cluster. And so if those were the typical capabilities, what a typical architecture looks like. Now, most of them follow this pattern. So take this as a very high level. You'll have a control plane and a data plane. Control plane is the thing that manages all the rules and applies them down to the data plane. The data plane is where your workloads run, and typically, I think most of the meshes will inject some sort of proxy next to your workload to intercept all the traffic. So now we know why we would need a mesh. We've sort of spoken about what a mesh is. So something to think about is, are these technical capabilities the only things you should be worried about? Now, in discussions with a number of customers, we've come up with a list of things they'd like to consider when looking at meshes. So obviously the first item up there, technical, we've covered that all off with capabilities. To some businesses, commercial support is important. In this cloud-native world, everything is open source, and that's fine, but something as important as a mesh, some businesses may actually want some sort of commercial backing behind it, or someone they can actually get on the phone, because some of these setups can get quite complex. Some people may not think that the commercial support is too much of an issue, but they may want to look at the governance, or if it's backed by a foundation. Sometimes those type of things are important to certain customers. And then other customers may be, they may not like to take on board certain OSS licenses. So I think most of these are fairly permissive, but if you're looking at this from a business point of view, make sure you ask these type of questions, because you may get far down the road and then find out the business won't let you actually run it. And then once you've got the service mesh into your cluster, some of the things you need to consider are, how easy is it to install? How easy is it to configure? And have you run an upgrade on it before? Because remember that a service mesh is actually sitting in front of all of your workloads. So if you mess up an upgrade, you're going to take down everything. So something that's been, if you've been following the service mesh space for a while, something that's been coming up of late is overhead of running a service mesh, and that's typically been tilted towards Istio at this point. They're doing a lot of performance enhancements, so those overheads are coming down. But you'll see a lot of benchmarks out there. Make sure you read them carefully, because a lot of them are sensationalized. There's one I'll go through later, which is actually done very in-depth and methodically, and it's actually worth reading through that one. But it is something to be aware of. All of this magic doesn't come for free. Something is effectively in the path of all of your calls. So integrations is another operational aspect you should consider. If your business has invested, say in Azure, you've invested in pulling all of your metrics out into Azure Monitor, you want to make sure that whatever mesh you put in there, you can actually extract all of the information out and put it into your monitoring system. The last thing I have in operational there is mixed workloads, which it's an interesting way to say Windows and Linux workloads. So the last, I think, Windows G8 and Kubernetes 2 releases ago. So there are definitely customers who are starting to run Windows workloads in conjunction with their Linux workloads in their clusters. As of this moment, none of the meshes work in Windows. That's because of some of the fundamentals at the networking layer. Consul is the only one that works in a degraded state at this moment with Windows. So if you are running clusters with mixed workloads, that's also something to consider. And then, as I mentioned a little bit earlier, security is something that comes up. Once you start having this conversation with customers who are very aware of encryption or compliance, the fact that most of these meshes are auto-generating self-signed certificates doesn't cut it. They want external certificate authorities. Vault, HashiCorp's Vault can be injected into most of these environments to provide an external source of certificates. But just have a look at that. And also, management and rotation is important. Istio recently had an issue where people who've been running one of the latest releases, well, I think version 1 for about a year, suddenly all their certificates expired, and there was no way to rotate them. The various meshes make this easy, that they have different ways of approaching this. But again, if this is important, make sure you ask that question. And then these are questions I like to ask to get to the point is, should you even be running a service mesh, or should you even be considering it? A lot of people will come to us and go, yeah, I'm installing Istio and I'm trying to route traffic at the ingress. And you go, well, just run an ingress controller. Are you using any of these other capabilities of Istio? No. Well, let's just run an ingress controller. And then certain workloads and environments cannot tolerate the additional overhead. That's either compute, memory, network latency. They just cannot tolerate those additional overheads. Those type of environments, maybe look at a different solution. And then, is this adding additional complexity? When these meshes were shiny and new, everyone wanted to just deploy one. Once you start asking questions, they actually don't need them. So think about the additional complexity that you're putting into your cluster, or if you actually need it. The bottom question there, can this be adopted in an incremental approach? We're starting to see a lot more work around this, where you can start to adopt service meshes piecemeal. So maybe you can get mutual TLS as the first step, and then if you need to add another capability, you can add something else into the mesh, or add additional components of the mesh that will give you those additional capabilities. So now, let's dive into each of these. So these are the three meshes that most people are talking about at the moment. And these are the most full-featured meshes. There are a number of other options, but they're all quite niche for specific types of workloads. So let's look at Istio first. So I've said this is a full-featured, customizable, and extensible service mesh. That single line there tells you everything you need to know. Full-featured means it's quite heavy in terms of the cognitive load that you might have understanding all of the components that are involved. there's also a lot to install. There are a ton of components that actually make up an Istio cluster. So it was announced, just over 2 years ago, GA'd last year. Google and IBM own the governance of this, and it's Apache 2 license. For those who want commercial support, there's a company called Aspen Mesh who have I think it's an offering that's based on Istio that they can put into your cluster, and they will offer you commercial backing. There's also managed versions of Istio. So in Google Cloud and IBM Cloud, you will see managed versions of Istio, which make it a lot easier for customers in those clouds because you can essentially tick a box and you've got Istio. That doesn't absolve you from actually having to know what's going on, but it makes some of the installation a little bit easier. What I've also done with each of these meshes is put up the design goals of the project, and that sort of tells you where their focus is at the moment. So Istio's design goals are maximize transparency, so they want you to just be able to deploy it and things must just work, which to a fair degree they do. Extensibility and portability are their two key design goals, and you can actually see that in how Istio is built. There are extension points everywhere. It pretty much looks like Kubernetes. You can extend any aspect of it. You can put in custom metrics. Literally every single point is an extension point. But that adds to its complexity in terms of understanding. And then policy uniformity was something around them not baking policy into their sidecars, but bringing the policy out. I didn't quite understand what that design goal actually alluded to. This is a diagram of some of the components for Istio. So at the bottom we've got the data plane, at the top we've got the control plane. Pilot essentially sends all the configuration to each of the proxies. Galley is the configuration manager. Citadel is where all the certificates are managed. And then Mixer is the central hub. So Mixer will actually gather metrics from each of the proxies and will also, it's what the proxies check for policy matches and all sorts of other things. So Mixer is essentially the hot path. I've put Prometheus and Grafana there in gray because you can deploy them as part of an Istio installation, but they're not required. At the bottom, something important, you can notice there's a Kubernetes node and a virtual machine. What Istio allows you to do is extend your mesh outside of your cluster. So you can essentially have the service mesh in your cluster. You can also extend it to virtual machine workloads that you may be running outside of your Kubernetes cluster. Another aspect of this is gateways. So Istio also allows you to communicate between two clusters. So that's another concept around this. So Istio has a ton of capabilities. It's got the gateways, as I mentioned, multi-cluster expansions with VMs. It's got a ton of traffic management capabilities, policies. Their security is pretty impressive. You can do end-to-end authentication and routing based on user authentication and authorization. So they understand your tokens. They also support external CAs through HashiCorp Vault. Observability, they have all the golden metrics, mirroring, tracing. Custom adapters allow you to plug in adapters that can take your metrics to an external system. So you don't have to rely on the systems that come with Istio. Just a heads up, complex installation. Who has installed Istio before? Easily? Yeah. So if you've installed the demo, that doesn't count. If you've actually had to go through all the Helm configuration options, it's quite complex, and that comes down to one of their design goals. It's extensible, so there's a lot of things that you can actually do. You need to understand what you're doing. And then resource overhead, it's because Istio has been getting a lot of bad press in terms of overhead. I don't think it's as bad as some of the blog posts make out to be, and we'll talk about this in the benchmarking section just now. Managements for certificates is still not where it should be in Istio. Operationally, install via Helm chart, upgrade via Helm chart, and you've got auto injection of your proxies. So that's all good. There's an operator in the works, so you don't have to do it with Helm anymore by hand. And then in terms of scenarios, which are the sweet spot for Istio, if you require extensibility in a rich set of features, this is probably the mesh for you. Mesh expansion, if you have VM and Kubernetes workloads that you want to be in the same mesh, it's also a good option. And if you have multiple clusters and you want a mesh to span them, this is also a good option to look at. So next, we're going to look at Linkerd. So easy to use and lightweight service mesh. If you've ever run through the demos for this, it gets you super easy. So it was announced also 2 years ago. It's actually, the current Linkerd is version 2. The first version was written in Java. This one is written in Go and Rust, so it's a complete rewrite. And version 2 came out last year. So the governance of this rests with the CNCF. It's also an Apache 2 license. And Buoyant offers commercial support. So Buoyant were the people who originally built Linkerd, but it's an open source product. So their design goals, you can see, are very different to Istio's. Keep it simple. So literally everything they do is built around this. Keep it simple, minimize resource requirements, and just work. So you can see where their target market is now. So it doesn't look too different in terms of their architecture. I didn't put Prometheus and Grafana in gray in this picture because it actually installs. You have no option at this point. I think they're about to change that, but for now, it comes with everything. They've got a lovely web UI. With Istio, you have to install something like Kiali to get a web UI. Linkerd comes with a web UI, visualizations, everything built in. They have the components at the top there, controller. Those are the rules for each of the proxies. Tap, essentially like TCP dump or mirroring, where you can actually siphon off traffic. And then identity is their certificate management. You'll notice that they only run in Kubernetes. So this is a very simple, lightweight mesh. So capabilities at a mesh level, they've got some interesting new stuff that they've just released around debugging. With a few CLI switches, you can actually inject some debugging capabilities, which will give you some insights into the proxies and whether they're working correctly. They've got some basic traffic management. Their security is pretty awesome. They do auto-rotation of their certificates every 24 hours. But you can't deploy an external certificate authority at this point. So again, decide what is important to you. Observability, they have all the golden metrics. TAP is amazing. Service profiles is really, really cool. If you have REST APIs and you have an open API spec, Linkerd can actually ingest that and will give you metrics per route with RPS and all sorts of other stuff. Their web dashboard with topology, all that sort of stuff. So heads up, small set of features. This is really lightweight, but if these capabilities are what you need, then I would steer you in this direction. The other thing which is quite apparent, if you need to deny or allow traffic as part of your mesh, they don't support that yet. And there's no tracing support. There's no tracing like with Jaeger or open tracing. They actively have a request for comment out at the moment. So if you want to participate in shaping traffic for Linkerd, reach out to them on Twitter. Operationally, super simple to install via their CLI. The other cool thing is they do pre and post checks with their CLI. So you can see if your cluster is in a good condition to install it, pre and post the actual installation. They've also focused on splitting up the installation for your different security roles. If within your organization you have a security role or a cluster-wide administrator versus a namespace administrator, they've actually separated everything out to allow you to do that easier. Istio has also started to look at doing that. They've got built-in high availability mode. It's just another switch on the CLI and it will stand up high availability for the control plane. They've got built-in upgrade and they auto-inject. So the scenarios where this would suit the best, small set of capabilities. If you're after just what they've got, then works well. And if you're interested in low latency, they're really focusing on single-digit latency for their proxies. Let's have a look at console now. So console came from a world that wasn't service meshes. And this is very apparent when you try and use it for the first time in the service mesh context. So it's a multi-data center where service mesh connects and secures services across runtime platforms. So this means their design principles run and connect anywhere, extend and integrate. So they want to be able to connect your workloads wherever you're running them, whether it's different clouds, whether it's on VMs or Kubernetes, wherever they are, they want to be able to connect them. So this was announced, I mean, console is fairly old. The connect capability, I think, is fairly recent. The governance is through HashiCorp, Mozilla public license too, for their OSS license. Obviously, commercial support you can get via Console Enterprise. You can see that this looks very different to the other two diagrams. So with console, you have to run a set of console servers within your environment. That could be in your Kubernetes cluster. It could be on virtual machines on your same network. Wherever they are, there needs to be a quorum of those console servers. And those effectively are the brain or the control plane. And then there's aspects of the control plane in your workloads as well. Console has this concept of server and client. So the clients have to run next to your workloads, and those will communicate with the server. And then you'll have the proxies down in your workloads that will communicate with the client. Again, you can do this on a Kubernetes node or on a virtual machine. So this set of capabilities is impressive. They've got multi-data center gateways. Because console was a multi-data center aware product to begin with before it was even had service mesh capabilities, you can stand up multiple data centers, console data centers, and it can connect them. It can also talk to virtual machines. It does service synchronization. So console has a concept of a service, and Kubernetes has a concept of a service, and it can do synchronization, two-way synchronization to make it easier to work with. There's also built-in debugging. So the proxies, what I want to specifically call out here is this is the only mesh, if you have Windows workloads, that has limited capability to understand some of the traffic coming out of those workloads. They've just started working on the traffic management. Some of the basic stuff is there. Their policies are fairly powerful. You've got accept and deny, and then ACLs, you can issue tokens that will set up their whole policy. Security, they've got all the stuff you need there. They've also got, obviously, integration with Vault. It's one of their products. They do certificate management and rotation. So if all of that stuff's important to you, this is probably something to look at. And they've got all the metrics, the UI dashboard, everything. So heads up, if you thought Istio was complex, console is also very interesting. There are a lot of moving parts, and you need to actually have a basic understanding of console before you can even get up and running with this as a mesh, because you're actually installing console and switching on Console Connect, which is the service mesh feature inside of console, but you still have a whole console environment running. They don't have any tracing support at the moment. Also, if you've been using Kubernetes, well, everyone is using Kubernetes DNS to communicate between the different workloads. Console does not use Kubernetes DNS. It uses its own concept of a service. This can be a little bit tricky to understand. That bottom point, they all listen on localhost, so you don't actually talk to a service on another service. You essentially set up localhost aliases, and those clients do all the forwarding for you. So it takes takes a bit of mental gymnastics initially to get through how that's working, but once you've got it, it's actually very powerful. Operationally, installation via Helm chart, and the proxies are auto-injected. Scenarios where this works best, if you have existing console-connected workloads, this is a natural extension. If you have strong compliance requirements around certificate management, this is also a no-brainer. And like Istio, if you have multi-cluster or VM-based workloads that need to be included in the same mesh, this is also a very good option. So those are the meshes. So let's look at the topic that has come up very often when people speak about meshes. They'll typically, the first thing will be, oh, this is so awesome. I can get all this stuff for free. And then after a week, they go, why is everything running so slowly? I don't know what's happening. These are things you need to be aware of. So within the benchmarking discussion, the first well, it's not even a product, it's an open source project. Lee Calcote started this. He's written a ton of Istio books. Read his stuff and watch his talks. He's amazing. He's built this thing called Meshery, which allows you to start doing some basic performance benchmarking within your own cluster. So you can actually use their CLI, inject this into your cluster, and we'll actually start pulling metrics. It's fairly simple at the moment, but it's a good start, and it's a community effort. If you're interested in this aspect of service meshes, I would participate. This is the latest benchmark analysis that actually has been pretty comprehensive. So Linkerd actually asked Kinvolk to do a independent third-party benchmarking shootout between Istio and Linkerd. Now, Kinvolk have Istio customers, so they didn't want to paint Istio in a bad light. So this has been a very thorough investigation. There are probably 40 graphs. I can't show them all here. The message I'd give you, have a look at this. It's very interesting. Kinvolk actually went into the way that we do benchmarking and said most benchmarks are incorrect. Most people are only looking at the P99 or below, to all those small bars at the top. And Kinvolk is saying, if you actually go into the analysis of how benchmarking is done, you should be paying attention to those upper nines, so all those long bars on the right. And if you look at those, most of them are all looking the same and very high. It's a very in-depth topic. If you're interested, read this blog post. It'll open your eyes about how to benchmark properly as well, and what metrics actually matter. Now, we've talked about all the differences. There's also been some work going on at the moment to standardize what a mesh looks like. And this is the Service Mesh interface. So this is a standard interface. It's really early days at the moment. It's basic feature set. It's flexible. And the bottom thing, space for the ecosystem to innovate. So that all the people on the right there are all the partners who work together to knock out the first cut of SMI. It's an open source project, specs open source. If you want to contribute, if you have strong opinions about what should be in the specification, reach out and contribute. So in terms of the specifications, there's specs that control access control, how traffic is routed, traffic splitting, and traffic metrics. You'll see there's nothing in there about a whole bunch of other capabilities that we're interested in. When this first came out, some of the pushback was, this is going to be the lowest common denominator. Whatever implements this is going to have like a half experience, and it'll be a rubbish service mesh. I was one of those skeptics in the beginning, but what we've started to see now is the actual tool vendors are the most excited about this, because all of a sudden, they're tools that only used to work for Istio that now are implementing against these interfaces, and now that tool is available for all the meshes. So yeah, watch this space. So as I said, there's some early support for Istio, Linkerd and Consul. The tool specifically I was talking about was Flagger, which is a Canary tool. And they have just implemented, they only used to support Istio. They've implemented the traffic split API, and out the box they now support Linkerd because of that. Solo's Service Mesh Hub is also looking at Service Mesh interface. As I mentioned, Kiali, and then there's KubeCost, which is cost optimization of your cluster. So Flagger is something I spoke about. If you're doing canaries releases within your cluster and you have a mesh, what they would do is work with Istio. They also work with AppMesh from AWS, and then Linkerd now through SMI. Start having a look at some of these tools, because you may be doing this by hand if you are in a service mesh at the moment, but this tool makes it really easy. What Flagger will do is it will do progressive rollouts of your canary. So you can say, I'm releasing something. It'll automatically release 1%, do some tests, release 10%, and you can set up that progressive rollout, and it can do rollbacks and roll forwards and a whole bunch of stuff. So this here was just showing that now with the SMI traffic split specification embedded in Flagger, they can actually support Linkerd now. I wanted to go back to Meshery. So Meshery, in addition to its benchmarking, it also provides a playground. So this is also super cool. If you install the Meshery in your cluster, you can say, I want to run Istio, or I want to run Linkerd. They've got a whole bunch of different providers, and that'll actually spin it up in your cluster, and you can play around. They have a lot of the samples which you can auto-inject. So if you just want to play around with different meshes, it's a really cool example. And then Lee also runs the Layer 5 IO website. If you want to know anything more about the service mesh landscape, he has done a ton of research. Solo has also got an awesome tool called the Service Mesh Hub, similar concept. They allow you to play with the different meshes within your Kubernetes cluster. They also allow you to add different extensions. So you could add Kiali and Flagger into any of your meshes. They've also started designing a specification around the extensions. So I think they're actually hoping that this will be some sort of community hub where people will build extensions. You can use this to deploy your meshes, test things, inject extensions. So just to wrap up, those are the three service meshes which I think you should start looking at. Istio a year ago was pretty much the only real option. Linkerd is starting to accelerate what capabilities it's adding, and Consul now with the Connect capability is actually a very strong contender. So it's a very active space. Make sure you ask all those questions I spoke about. Make sure you understand what you need, not what the mesh is giving you, and that will guide you towards what mesh to deploy. Definitely understand the impact of deploying a mesh. Have metrics in there, use one of the benchmarking tools, understand if the impact to your cluster, whether it's at a resource level or a latency level, is sufficient or acceptable to you. And then definitely keep an eye on the standardization efforts. SMI is still early days, but it feels like it's starting to open up conversations about better collaboration or integration of tooling. And then the Service Mesh Hub, Meshery, and Flagger are also definitely things you should look at. Thank you very much.